So now in this video, we're going to look at a simple circuit using the PNP bipolar junction transistor. This is the 2N2907. It has a lot of the characteristics of the NPN bipolar junction transistor 2N2222, except for polarities are opposite. So basically you can make the same circuits but opposite polarity. So we're going to look at that in this video. So to begin with, we're going to use the trimpot as a signal, and in fact I want to output a negative signal since we're going to use a PNP bipolar junction transistor. And so we have the red probe is basically ground, and then the black probe is our signal. I have that backwards. There we go. We want to do it this way. There we go. So now we got a negative 5.5 volts. We are going to adjust this. So that's going up. So we'll just turn it until we have about a spot on 5 volts. Close enough. So we are going to power an LED directly from the output there. So the output we're going to make more negative. So the short lead, the cathode, is going to the output of the trimpot. I'll move it down one more just so it's a little easier to see. Long lead anode's there, and then our ground's going to be the positive rail, which is a little odd, but that's the more positive side of the circuit there. So as you can see, the LED is not terribly bright. The brighter the light, the worse it will look. So that's about the brightest I will set. But in any case, we can look at the voltage across the LED. So again, we're going to make the red rail the ground, and so our signal there is dropped to about negative 2 volts, and so the output of this is about negative 2 volts more than the positive rail right there, which is our ending point. So what we want to do, we want to use a transistor just like we did with the NPN to not amplify the voltage that this will output, but to amplify the amount of current that can be output. That is why the voltage is dropping there. We can't supply enough current through the trimpot because of its internal resistance. So a load really throws that off. So we're going to grab the 2N2907 PNP type transistor. The left pin is the emitter, middle pin is the base, and the right pin is the collector. There, it's a little easier to see there. So we're going to put the load to the emitter, which will be lower on the board. And so we'll plug that in next to the trimpot. So the output, the middle pin, the base, is where the output of the trimpot is. There we go. We'll wiggle that down. So now we are going to put the collector to the negative rail. For the NPN transistor, it was to the positive rail, but this is opposite polarities. So we're going to go to negative. Before we do, let's make sure we add resistance so we don't forget to the emitter side of the resistor. And okay, this is a 1 kilo ohm resistor. I was looking at the color code to make sure. And so again, the emitter opposite of the NPN is going to go to the positive rail instead of the negative rail. And then the collector up there, I will grab a gray jumper, and so you'll see this 2 rows. I'm gonna flip that before it starts beeping, telling me that I forgot to turn it off. So we're gonna put a gray jumper right to the collector, and there we go. So 2 rows up, it goes to the top pin of the transistor, and then you can see that resistor goes to the emitter, and the base is the trimpot there. So I left the power on. So again, we're going to go to the negative rail for our ground, and the output of the trimpot is 5 volts, but the transistor now, we lose a fraction of that voltage. And so actually I want the black probe to indicate ground. There we go. So there we go. And so we have a negative voltage there in relationship to ground. So we're actually following the electron flow in this case. So that's a little confusing, but that's one reason why I'm doing more PNP transistor videos and trying to get better at explaining them. So in any case, we have a negative voltage from the signal to our final destination, the positive rail, and we're losing some of that negative voltage. So let's see if I can hold this. But in any case, we need to set the transistor. That's not working well at all. Okay, we need to set the transistor so that it's negative 5.7. So I'll go a little bit towards the negative rail. That went a little bit above 6. Let's go down. And this will work too. Just I'm trying to get 5 volts, negative 5 volts at the emitter here. So we have negative 5.8. So we're going to have probably just a little bit more than 5 volts at the emitter there. So there we go. A little bit more. Let's run with this. So we're going to deal with 5.2 volts instead of 5 volts. But just remember, we have a diode drop below the power source voltage. But as you can see here, now we have a voltage there of 5.2 volts in this case. So we're going to grab the LED. It's a negative voltage. So the cathode, the short lead of the LED, is going to go to the emitter of the trimpot. And then we're going to use a protective resistor. We only have to protect it from 5.2 volts. And so a 220 ohm resistor should work. So I'm putting one side to the positive rail and then the other side to the anode, the long lead of the LED, because it goes to the positive side of the power supply. And I just shorted that out there. And no big deal though, they both go to the positive rail. And so the transistor just had a little bit more current go through it. But now we also have the LED voltage drop. But in any case, again, we'll go to the positive rail, try to remember that is our ground. And the LED is a lot brighter than it was at the beginning of the video, when we tried to put 5 volts across it directly from negative 5 volts directly from the trimpot. Here you can see we got negative 5 volts, and the current that can be provided is amplified by the transistor. So the voltage in this case is not amplified from the signal. It is the amount of current that the transistor will provide. And since the signal cannot provide much, the transistor takes over in the current needed to hold that voltage at the emitter. So hopefully this video made sense. The emitter amplifier is really my favorite transistor circuit. I like that you can take a weak voltage and power something else with that voltage. You can easily program the voltage. The breadboard, of course, is 10 volts. You need a higher voltage. You don't use it to control the exact same amount of voltage. You have a higher voltage because there is some power loss in the transistor, and we also had the diode drop we had to account for. And so you need a higher voltage power supply than the signal you're sending, but ultimately you can reduce its voltage really easily with the transistor, the voltage from the power supply going to the load. So thank you for watching. I will see you in the next video.